Hi, I'm Rachel Rose, and I will be going over the solutions for the Week 8 Tuesday assignment for Calculus 2 by Professor Insco. So this assignment deals with setting up arc length problems, not solving for them, just setting them up. So the general formula you need to set these problems up is L, the arc length, equals the integral from b to a, the square root of 1 plus the derivative of f of x squared d of x. So let's take a look at the first problem. Find the exact length of the curve y equals 1 plus 6, 3 over 2 over x on the interval x, 0, 1. So the first thing we should do is set up a graph and see what this curve looks like. And if you do that, you should get something that looks like that. Now all we need to do is take this information and use it to plug into this formula. So the first thing we need to do is find the derivative of y. Y equals 1 plus 6x, 3 to the 2. So if we take the derivative of this, you have the 1 cancels out. Then you have 3 to the 2 times 6 and minus 1 to the 3 over 2, and you get something like dy equals 9 1/2 over x dx. And if you plug that information into this portion of the formula, along with plugging these into b and a, you should get L equals the integral from 1 to 0 square root of 1 plus 9x 1 over 2 squared dx. And if you simplify this out, you should get the integral from 1 to 0 square root of 1 plus 81x dx. And that's it. That's all that needs to be solved for the first problem. They're that simple. Now the second problem. Find the exact length of the curve y equals x cubed over 3 plus 1 over 4x, for 1 is less than or equal to x, which is less than or equal to 2. So getting a look at what this function looks like, it should look something like that. And same for the last problem, we're going to take the derivative of y equals x cubed over 3 plus 1 over 4x, and since this is equivalent to 1/3 x cubed, you take the 3, that cancels out with the 1/3 and 2, so x squared, and you have 1 over 4x, which is the equivalent to 4x to the negative 1. And if you simplify all of that, you should get a derivative of dy equals x squared minus 1 over 4x squared dx. And if you plug this value into the arc length formula, along with this for b and a, you should get L equals the integral from 2 to 1, the square root of 1 plus x squared minus 1 over 4x squared dx. And simplifying that out, you should get the integral from 2 to 1, the square root of 1 plus x to the 4 plus 1 over 16x to the 4 dx. And that's all for number 2. Moving along quickly to number 3. Find the exact length of the curve y equals ln secant of x on the interval x 0 pi over 4. So now we're getting into trig, and like usual, we should probably find the graph for this, and it should look something like that. Excuse my poor handwriting. This tablet is awful. Anyway, we should, like all the rest of the problems, we need to take y equals ln secant of x and solve for the derivative. And if you know your trig properties, you should know that this should equal dy equals tangent of x dx. And plugging this into the arc length formula, you should get L equals the integral pi over 4 to 0 square root of 1 plus tangent of x squared dx. And simplifying this out, you get the integral of pi over 4 to 0 square root of 1 plus tangent squared of x dx. And that's it for number 3. Now number 4 is a bit more complicated, but we'll get to that in a minute. Find the exact length of the curve y equals 1/4 x squared minus 1/2 ln of x on the interval x1, 2. So the graph for this should look something like this. And now we need to take the derivative of, y equals 1/4 x squared minus 1/2 ln of x. 2 times 1/4, and since ln of x, the derivative of this is 1 over x, the derivative you should get is dy equals 1/2 of x minus 1 over 2x dx, and plugging this into our arc length formula, you get L equals the integral from 2 to 1 square root of 1 plus 1/2 x minus 1 over 2x squared dx. And now, if you multiply this by itself, you can simplify the problem, and you should get the integral of 2 to 1 square root of 1 plus 1 over 4x squared plus 1 over 4x squared, the derivative, minus 1/2 dx. And we're not done yet, because this 1 can be simplified with this minus 1/2, and the integral from 2 to 1, the square root of 1/2 plus 1/4 x squared plus 1 over 4x squared. And that's a dx. And that's it. That's all there is to these problems. They're relatively simple and easy to set up. Thank you for watching. Bye.